Assalamu alaikum, my dear cadets of class 9. I welcome all of you to my online physics class of Burishal Cadet College. During this ominous cloud of COVID-19, you were not able to stay at your second home. That's why our academic program is being hampered. So this online effort that has been taken by the authority of Burishal Cadet College to carry on our learning process. My dear cadets, during this corona outbreak, please don't go outside of your home. Please stay home, stay safe. Before starting my class, I would like to introduce myself. This is Mohammad Kamrujaman Khan, lecturer of Department of Physics, Borishal Cadet College. This class for class 9, subject physics, chapter 5. Name of my today's chapter is Pressure and State of Matter. But at first, you should try to observe this image and try to guess what should be our today's lesson. Yes, our today's lesson is about pressure, and I will discuss along with this pressure on submerged body, Archimedes law, Pascal's law, density, and finally application of density. Learning outcomes. By the end of my today's discussion, cadet, you will be able to explain the change of pressure with the change of force and area, determine the pressure at a point inside a liquid at rest, explain Pascal's law, explain the uses of density, explain the theory of Archimedes, explain why objects float or sink into water. Key points of my today's discussion: pressure, density, buoyancy, Archimedes law, and Pascal's law. At a glance, what I have discussed in my previous chapter: work, different forms of energy, conservation of energy, power, and efficiency. Okay, my dear boys, let's have a closer look towards pressure-related discussion. At first, fluid. Substances are classified into different forms. Fluid is one of them. A fluid is a substance which flows or capable of flowing. Liquid and gases can flow easily, so they are called fluids. The fluids can create pressure. Okay, what is pressure? Pressure is force that is exerted perpendicularly to per unit area of a body, and this pressure is denoted by a letter that is P. P is equal to F divided by A, and its unit comes from this equation is like that: Newton per meter square, or simply Pascal. What do you mean by 1 Pascal? It is a very burning question for understanding level. Okay, have a look. If a force of 1 Newton force is applied perpendicularly to an area of 1 meter square, then the pressure generated is called as 1 Pascal. Okay, dear boys, look at here. 1 Pascal means the area and force should be unit, but it never be unit for 10 Pascal or 5 Pascal. Let us suppose I'm going to define what do you mean by 10 Pascal. 10 Pascal means a force that is 10 Newton force is applied perpendicularly to an area having 1 meter square, then the pressure generated is known as 10 Pascal. Okay. Now I'm going to define what should be the dimension of pressure. Here, this is our equation: P is equal to F divided by A, and F is equal to MA over A. So from this equation, we can write this is capital M and LT inverse 2 for acceleration and L square for area. And after calculating, we can write this is the final form of dimension of pressure, that is ML inverse 1 T inverse 2. Look at this picture. Okay, you can see here force is applied. For applying this huge amount of force, this pressure is increasing. So it is very much clear that pressure is proportionally related to the applied force. If force is increasing, pressure will be increasing, and if force is decreased, pressure will be decreased. Now, density. Yes, it's a very important matter for the pressure and state of matter chapter. We have to know before starting density what is volume. Volume is a space occupied by a body. It's called volume, and it is denoted by V. Here, this is V, and its unit is cubic meter, dimension L cube, and density is like that, the mass per unit volume of a substance. And it is defined by a letter, that is G or Rho is equal to M over V. Its unit comes kg per meter cube, and its dimension from this equation, it is coming ML inverse 3. I'm repeating it, its unit is ML inverse 3, and it is coming from this equation. Okay. Density is a general property of matter, and it is depend on material and temperature. And the density that is measured by a device is called hydrometer. By using hydrometer, we can determine the density of a material. Some substance and their related density. Okay, have a closer look towards this chart. Here, this is air and its corresponding density is like that, and this density is considered here in kg per meter cube unit, and this is cork, glycerin, water, iron, silver, ice, coal, kerosene. So boys, it is very, very important to remember you the density of kerosene and the density of water. The density of water is 1000 and kerosene is 800, and this is very burning question for us. So you should try your level best to remember this two quantity as well. Application of density. There are different types of application of density, but I am discussing here some of them. The balloons are puffed up by hydrogen gas, and this gas is very considerably very less than that of the density of air. So this balloon goes up upward direction very easily, and the cell will damage if the density of acid increases. Then for this region, necessary amount of water is added to its time to time to keep the density at desired level so that this cell will not be damaged. Eggs sink in water, but rotten eggs remain floating. As the density of the rotten eggs is less than that of the water, that's why it floats on water. And iron sink into the water, but ship floats on water. My dear boys, you will know about the condition for floating and immersion in our next slide. So cooperate me and we are going to discuss about pressure at a point in a liquid. It is a very important equation. So have a closer look. Okay, let's see this part. This part is filled, half filled with water, and there is a substance having cross-sectional area A and its height is H. Now, the weight of the column of liquid above this area will exert a force on A. The volume of the liquid over a surface area A is AH. And if the density of the liquid is rho, then weight of this liquid or force is F is equal to mg. And you know it very well from our density that rho is equal to m over v. From this equation, I can write m is equal to rho v, and v is replaced here by ah, so it becomes ah rho g. Now we are going to calculate pressure. Pressure is equal to F over A. So after putting this value, we are getting final equation for pressure H rho G. My dear boys, it's a burning question for us, and you should remember it in your mind that the density of different material should be varied, and for this variation of density, the pressure of any substance inside the liquid or inside the fluid should be different. Even the height of material that is immersed in water or any type of fluid is same, but the pressure will not be same because density of each and every material is different. Okay, let's have a closer look. Trying here to make you understand about the amount of pressure. Okay, this water level is classified here into two layers. This is first layer, and the height of this is like that, and for that this height is very low over the water surface. That's why weak flow is here, and this is higher height from that of before. That's why this flow is strong, and from over the surface of water till this line, this height is very high. That's why this flow becomes strongest flow. So it is very much clear that when height is increasing, then pressure inside the liquid is increasing. Now I'm going to discuss about buoyancy. Yes, my dear boys, buoyancy is a very important part for you. So have a closer look about the discussion of buoyancy. Suppose if you would have gone to river to swim, then you might have observed that while you were going inside the water, that is, you are covering distance inside the water, somewhat force is exerted by water on you. And this force always wants you back over the surface of water. So, and this force is known as buoyancy, and buoyancy is somewhat upward thrust. Okay, let's see what is buoyancy. The definition of buoyancy: if a body submerged or partially submerged into a liquid or gaseous medium, the upward resultant force acting on the body vertically by the liquid or gaseous substance is called buoyancy. Look at this figure. This figure is going downward direction, and this is due to the gravitational force, and this figure is going upward direction. This is due to the upward thrust of this liquid. So it is very much clear to you that the direction of applied force and direction of resultant, that is buoyant force is reciprocal to each other. So buoyancy is one type of upward thrust and it is exerted by the medium, that is fluid. It should be, or it may be gaseous medium or liquid, but it never be solid medium.
We're all aware of the fact that some objects float in water while others sink. Let's look at a balloon. Do you know what makes a balloon float on water? Well, it's the upward force exerted by water that makes the balloon float. To experience this, try pushing the balloon underwater. You will feel an upward force that makes it difficult to push the balloon down. Now release the balloon, it bounces back to the surface. What happens here is that the applied force acts in the downward direction, pushing the balloon down, but the water exerts an upward force on the balloon, pushing it up. This upward force exerted by water on the balloon is known as upthrust or buoyancy, and the upward force is called the buoyant force.
Okay, my dear boys, after buoyancy, we are going to discuss Archimedes' law. Yes, Archimedes' law is related with the submersion or partially or fully submersion of a body in a liquid. So let's see the definition, or let's see the law of Archimedes. If a body is partly or fully immersed in a liquid or gas, in equilibrium, it seems to have lost a part of its weights. And for this body feels very lighter than that of before. And this apparent loss of weight is equal to the weight of the displaced liquid or gas. And this is known as Archimedes' law. Now, upward resultant force or buoyancy should be equal to the weight of the displaced fluid by the cylinder or by the material. That should be equal to the apparent loss of weight of the object. Now, observe this image here. An object is placed inside the liquid, but we are not seeing anything here. Look at this picture beside here. Yes, when this object is placed inside the liquid, then somewhat water is displaced from this and it placed into the pot, and this water is called displaced water, and it is happened by the submersion of this body inside this liquid. Okay, and also you are observing here that the total weight, that is pound, that is considered here in pound, it is decreasing, and somewhat water is placed here and its weight is 3 pound, and it is 4 pound, but 3 plus 4 should be equal 7. So 7 is the total weight of this body when it is not submerged in water. When it is submerged in water, then it loses somewhat weight and it becomes 4, and the displaced water is 3, and this makes 7. So it is very much clear to you that a body, when a body is submerged inside a liquid, somewhat water is displaced by this object, and this body will lose somewhat force, and it is called apparent weight or force. Let's see the mathematical term of buoyancy. Yes. There is a beaker and it is water filled, that is half filled, and inside this beaker there is a object, cylindrical object, and its cross-sectional area is A. So this is the height of this object and this is the cross-sectional area of this object, and it is placed inside the liquid of this beaker, and the total height that is covered bottom of this object is H2, and the height that is up to the upper surface of this object is h1. So we are getting total height of this object from this h2 minus h1, that is h. Okay, if this or since this object is submerged inside the liquid, so somewhat force is exerted on this object by this liquid. So we are going to discuss about that matter, the downward pressure acting on the upper surface of the cylinder, acting upper surface of the cylinder. Okay, now this is P1 is equal to H1 rho J, and it's our equation. You have learned it from our previous slide. P is equal to H rho G, and here this is for H1 distance. That's why this is P1, and that's for H1 rho G. Now the upward pressure acting on lower surface of the cylinder, acting on lower surface of the cylinder. Okay, lower surface means that is covered distance H2. So it becomes P2 is equal to H2 rho G. Therefore, the downward force acting on upper surface and upward force acting on lower surface are respectively P1A, that makes our force F1, and it becomes AH1 rho G, and for F2 is equal to AH2 rho G. Now we are getting somewhat resultant force because the acting force of this are, there are two acting force here, and the direction of this acting force is vice versa. That's why we'll get some resultant force here, and this is the resultant force. So resultant force is becoming F2 minus F1. From this equation I have written here AH rho G, because H2 minus H1, that makes H. H2 minus H1, that makes H. So it becomes AH rho G, and A is replaced by V. This is volume. So this is our concern or desired equation of buoyancy. So buoyancy F is equal to AH rho G or V rho G. Okay, this is precisely known as the Archimedes law. The upward force is called buoyancy. Let's have a closer look towards a video on Archimedes' principle.
Archimedes' principle states that when an object is immersed in a liquid, the apparent loss of weight of an object is equal to the upthrust, and this is also equal to the weight of the liquid displaced. We see the uses of this principle in our daily lives. Ever caught a fish with a fishing line? When pulling the line, you would have felt the weight of the fish in water is lighter than when the fish has surfaced. Say the weight of the fish in water is 4 kilos. Its approximate weight outside would be 5 kilos. Well, the water level too has come down. This difference in the volume of water level will equal the loss in weight of the fish when in water. That is, the weight of the fish when outside minus its weight when immersed in water equals the loss in weight of the fish. So the loss in weight of the fish will equal the weight of the decreased water. This is because the upthrust or buoyant force is equal to the weight of the decreased amount of water. Thus, Archimedes' principle is verified.
My dear boys, after observing this video, I think it is very much clear to all of you that what is Archimedes' law and what is buoyancy. Okay, let's see this math. Okay, our first question, calculate the density of the material of the object, and solution is like that. At first, I have written here M is equal to W over G. From this equation, M becomes 1 kg, and volume A is equal to like that, and this volume is converted here because this is in centimeter and meter square unit, so we are getting cubic meter. Now density rho is equal to M over V, so this is our result. and density becomes 5000 kg per meter cube. My dear boys, it should be remembered in your mind that after solving any kind of math, you should use unit. Without using unit, math is incomplete. So it is mandatory to use unit after calculating any math. Okay, let's see second questions. This is second question. Does the stem follow Archimedes' law? Give mathematical explanation. It is very burning questions and a very important question for you boys. So have a closer look. Okay, at first we have to find out the amount of water or weight lost. Okay, now from this equation we can write that weight lost is equal to 9.8 minus 7.8. From this equation it becomes 1.96. Okay, and the actual weight must be considered when the material is placed in air, and the apparent weight should be considered when this object is placed inside liquid or water. Okay, we are getting weight lost from actual weight minus apparent weight. Now buoyancy, from our equation we are getting buoyancy is 1.96 by using this equation. So Archimedes principle is like that amount of weight lost should be equal to the buoyant force or buoyancy, or should be equal to the displaced water. So the weight lost and buoyancy force are equal. That's why this stem follow Archimedes law, and it is verified. Flotation and immersion condition of a body. Okay, here W1 and W2 is defined for the weight of object and for the weight of displaced water. Okay, if the weight of body is greater than that of the weight of displaced liquid or water by the body, then the body will sink into the liquid. Okay, and it will also be considered for density, and here inserted about this density. Look at this. If the density of the body is more than that of the density of displaced liquid of the body, then this body will sink inside the liquid. And when the weight of this object will be equal to the weight of the displaced water, or density of this object, or density of the material or liquid, then this body floats being fully immersed in liquid. And when W1 is less than that of W2, that is displaced water, amount of displaced water should be greater than that of the weight of this object, then it floats being partly immersed in liquid. And it's time to clear all of you about this immersion and flotation condition. Let's see this picture. Yes, here you can see that this body is floating. Yes, this body is floating because W1 is less than that of W2. And here W1 is equal to W2. So this body floats being fully immersed in liquid, and there is a similar case, the flotation of ice is also for this case. And here W1 is greater than that of W2, then this body will sink into liquid. I think this three condition is clear to all of you. Now I am going to start next. Pascal's law. My dear boys, Pascal's law is very much important for you. So have a closer look to understand this. Okay, my dear boys, what is Pascal's law? If external pressure is applied to any portion of a liquid or gas enclosed in a container is equally transmitted in all direction in the liquid or the gas without any trace of diminution and acts perpendicularly on the surface of the container in contact with the liquid or gas. Okay, my dear boys, I'm trying my level best to make you understand by using this diagram or demonstration of Pascal's law. Okay, let's see. Here, some water that is enclosed inside this ball, and there are some pinholes, and this by this piston pressure is applied here. So after applying pressure, what will be happen? Okay, let's see. When pressure is applied here, then this pressure is or when force is applied here, this pressure or force is circulate in all direction equally. And let's see, when this pot is filled with water and there are 1, 2, 3, 4 jets, and through these jets water can go out from this. But let's say when pressure is or force is applied by this piston, then liquid will rise up equally. So from this it is very much clear that pressure is transmitted in all direction equally. Okay. Let's say formation of multiplication of force by using Pascal's law. Here, let us suppose cross-sectional area of one cylinder is A1. Yes, this is cylinder 1 and this is cylinder 2. Here, the cylinder 1 is smaller than that of the cylinder 2. So, the area of cylinder 1 is A1 and cylinder 2 is A2. Okay, now F1 force is applied on this cylinder and this force is exerted on this cylinder 2. Now this force becomes F2. Here, the pressure that is circulated in all direction through this liquid is P is equal to F1 over A1. And now this pressure is transmitted through the liquid in all direction, and it will also be applied on the cross-sectional area of the second cylinder, and it becomes, therefore the amount of force applied on the second cylinder will be like that. F2 is equal to a P2, and after putting the value of P is equal to F1 divided by A1 into A2, and this is the application of Pascal's law, and this is known as multiplication of force. Multiplication of force means when we are applying small force but we are getting higher amount of force. Let's have a closer look towards the video on multiplication of force.
You must have heard the term hydraulics. Hydraulic machines are machinery and tools that use liquid fluid power to do simple work. According to Pascal's law, the pressure applied to an enclosed incompressible fluid is transmitted unchanged to every part of the fluid. Here, there is a model of simple hydraulics that uses the principle. It is a U-shaped tube which has two arms and they are closed by two leak-proof pistons. Now here, the two arms have different cross-section. One arm has much larger cross-section than the other. So here, we say A2 is greater than A1, where A2 and A1 are the cross-sections of the two arms of the U-shaped tube. Now, when we apply force which is equal to F1 to left piston, then it will create pressure which is equal to F1 divided by A1. As we know, pressure is equal to force by area. Now, the cross section of A1 is small. So, we can generate greater amount of pressure easily by applying a moderate amount of force. Now, this pressure will transmit equally throughout the fluid and reach the larger tube. Now, here in the larger piston, the pressure would be F1 by A1. So the total force working on the larger piston would be F2, and force as we know is pressure multiplied by total area. Here pressure is equal to F1 divided by A1 and area is equal to A2. So what is F2? F2 is equal to force divided by area. So this becomes equal to F1 divided by A1 multiplied by A2. Now, in case you have not noticed, the upward force applied on the second tube or the second piston is A2 times the force we applied on the smaller tube or the piston. So we see force gets multiplied many times. Thus, we can generate enough push to lift a heavy car by applying a much smaller downward push in the smaller piston, that is in the left arm. Thus, hydraulics is used to generate huge force by applying much smaller force in many heavy vehicles like bulldozers, trucks, etc.
Okay, my dear boys, I think after observing this video, application of Pascal's law is very much clear to all of you. Okay, let's see a math about Pascal's law. Here, question is like that: if a mass of 10 kg is exerted on a small piston, then what will be the upward force on large piston? By using the Pascal's law, we can write F2 is equal to PA2 is equal to F1 over A1 into A2. After putting this value, we are getting this amount of force, and this is 392, and it is much more greater than that of F1. So here we can see that the multiplication of force. Okay. Okay, my dear boys, at a glance, what I have discussed today. Today I have discussed about pressure on submerged body, Archimedes law, Pascal's law, density, and lastly, application of density. I have inserted here some sorts of questions on the basis of today's discussion. Firstly, knowledge-based questions. There are some knowledge-based questions. This is comprehension-based questions. You should try level best to solve these questions and make you understand about these questions. This is application-based questions, and this is higher order-based questions. My dear boys, you have already known about higher order-based questions, that higher order-based question is a combination of 4 types of questions. First question is about knowledge-based, and this is comprehension-based, and this is application-based, and lastly, higher order or higher ability-based. You should try your level best to solve these questions. If you face any difficulty, please inform me and I will help you, inshallah. Some sample questions, that is MCQ. Look at these MCQ questions and you should try your level best to solve these questions. Let's see home task. One CQ is inserted here. This CQ is like that. From this CQ, 4 types of question is inserted here. You should try your level best to solve these questions, and after solving, you must submit me through our BCC website and make 20 MCQ basis on our today's discussion. Okay, this is very important part to all of you, my dear cadets. Assignment will be open on Thursday through our BCC website for this discussion. Be careful and please attend in our assignment. My dear boys, if you have any query, please write in inbox and I will try my level best to answer your questions during my class. Yes, my dear boys, thank you for attending my online class. I hope that you must try to follow the instruction that I have given here. we know it very well that we are passing through a very crucial time due to COVID-19. During corona outbreak, going outside of your home is very risky for us. So never make any plan to go outside of your home, spend your time with your parents, never neglect your regular study. You should be very punctual about your online class. Stay home, stay safe. Okay, my dear boys, thank you very much. Stay home, stay safe.